Okay, in this question we're being asked to work out the concentration of chloride ions that will remain in solution at the endpoint when the silver chromate starts to form. Remember, that's when the silver reacts with chromate, which is the indicator. Now, there's not a lot of it, but it reacts with it. And we need to show that the amount of moles of chloride that remain in solution is at endpoint is less than 0.1%. So the endpoint is obviously crucial here. Now, if we write down the expression again, at this stage, initially we're interested in what's happening with the concentration of the silver ions at endpoint. So that's when this forms here. Okay, this solid that we can see. So we can work out the concentration of chromate. We know the Ks, and that means we'll be able to know the concentration of the silver ions at endpoint. Now from that we can actually work out, using the Ks for silver chloride, work out what the concentration of the chloride ions. Okay, and then we can just make a straight comparison from there. So again, with some of these questions, it's just getting a start and thinking about what's going on. And once you get a start, and often that's writing an expression or an equation, that helps you get going. And in this case, understanding that at endpoint, this is what's actually happening, therefore we need to get some information from here. Okay, so we'll write that out as I have, and we need to work out the concentration of the chromate ions. Now we're told there's 3 mils, there's this concentration, and so therefore we can work out the number of moles. And obviously if concentration equals moles divided by volume, then volume times concentration equals moles. So we just need to make sure we convert the mils into litres and do that calculation. Okay, and if we do that, we're going to get 0.003 litres times 0.1 moles per litre, and that's going to give you 3 times 10 to the negative 4 moles. Now the total volume is going to be the 20 mils plus the 3 mils for the indicator itself, plus 18.35 I think it is for the amount that's added to get to endpoint. And if we add that up, we get something like 41.35 mils. So that is going to go into calculating the concentration here. Okay, so rewriting that, we'll find that we have 3 times 10 to the negative 4 moles divided by 0.04135 litres. I've left out the units, but anyway, that's going to give us 0.007255 moles per litre of chromate. Now if we use the expression Ks, which is 2.6 times 10 to the negative 12, which we're given, equals the silver ions squared times by the concentration, which we've just worked out on that. Sorry, that's supposed to be a 5 there. So obviously we just rearrange that and calculate that, and we should end up with a concentration for silver, which is going to be equal to 1.89 times 10 to the negative 5 moles per litre. Okay, so we've now worked out that, and obviously that can now be applied to the Ks expression here to try and give us an idea of the chloride ions at that point. Okay, and rearranging, just writing out this equation, which is the Ks equals the silver ions times the chloride ions. If we do that and work out what the chloride ions will be, we should get a figure of something like equal to 9.36 times 10 to the negative 6 moles per litre. Okay. So what does this actually mean as a number? This is telling us the concentration of the silver chloride that is remaining in solution, because any other chloride ions will have formed a precipitate with silver chloride. So given that we know the volume and we know the concentration, we can actually work out the amount in moles of chloride ions that are remaining in solution. Now if we know the amount in moles of the the chloride ions at the start, that's where we can now make that 0.1% comparison and see if that's correct or not. Okay. So if we do that calculation, we find that there's it's just the concentration. I've missed out the units. You should include the units. That's just a bad habit of mine. times by the litres gives you 3.872 times 10 to negative 7 moles. That's the amount that's remaining in solution. So we need to find out how many moles there were to start with, and that'll give us an idea. Actually, what I really should be saying is here is how much chloride ions were actually used up in this. And we can actually get that in another way. We can just, for instance, it's silver nitrate that we're adding. So if we work out how much silver nitrate has been used up, which we're given that information, that will tell us how much chloride ions have been used up as well. Okay, so as it's a 1-to-1 ratio. So when the silver chromate starts to form, we should have that the silver ions should equal the chloride ions. So if we know how many silver ions are present, we should know how much chloride ions are present. So we know that the concentration is 0.05 moles per litre, and the volume is 18.35 mils. Of course, you've got to turn that into litres when you actually do this calculation. And if you do it, you find that you get 9.175 times 10 to the negative 4 moles. So if you do this calculation of 0.05 moles times 18.35 mils, turning it to litres, we get 9.175 times 10 to the negative 4 moles. And if you make a comparison between those two, that's obviously done just by dividing this number of moles by that number of moles, times it by 100, you should get 0.0, I think it's 0.042%, and that's obviously significantly less than 0.1%. So you've shown that in that calculation. Now, I wasn't quite happy with my explanation because I think there's more to this question than meets the eye. What is actually going on here? We're trying to find out how much in the way of the concentration of the chloride ions are in 20 mils of water. We're adding silver nitrate to it. The silver combines with the chloride to make a solid silver chloride. When all the chloride ions are used up, then the silver concentration will start to build up, and then it'll reach a point at which it will form a precipitate with the chromate, and we will see a change in colour. Now, the confusing thing about this is when we look at this, we see times 10 to the negative 10 times 10 to the negative 12. You would think that this would form a solid first. Now, this is kind of important. You cannot make direct comparisons between Ks values where one is the product of two concentrations and the one which is 4s cubed, the solubility cubed times by 4. You cannot make a comparison with these Ks values and just predict, which one's going to start to form a solid first. It's not that simple. Okay, so I just thought that was an important point to make. So once all the silver ions have reacted, and that's why then they start to react with the chromate ion and we get a colour change. And that's why for the previous part, if we know how much in the way of silver nitrate has been added, that tells us how many chloride ions reacted with the silver. So in other words, if we know the silver ion concentration, we know the chloride ion concentration, and that's what's enabled us to work out that percentage at the end. I hope that makes it a little bit clearer anyway.